In this video, we're talking about the importance of compound interest and how it relates to earning money for us. So, let's have the idea of a penny. Because we've been working with these exponential formulas, we know that our outside number is our principal, our inside number relates to our rate, and our exponent relates to our time. So, let's just talk about day 0 of having a penny being held in our hands. And we're gonna be doubling this penny over time. And because we've started at day 0, we have 1 penny. So we have a rate doubling of our penny at day 0 for 1 cent, which makes sense. We're just looking at the penny, we haven't done anything. Now let's go to day 1. If I'm doubling a penny, on the first day, I should expect to have 2 pennies. 1 plus 1 makes 2. Now on the second day, I'm going to have 4, because yesterday we had 2, and we're doubling each day. Now, we're going to just keep expanding this, and we see, already did that one, didn't I? 5, 6, and you think, okay, where are we going with this? If we're doubling a penny for this amount of days, let's look at what's happening in the span of a month. You'd have over $10 million. This is the power of compound interest. I believe it was Einstein who said, compound interest is the 8th wonder of the world. You're taking your money and applying a multiplier to it at a given time. We could compound every day, we could compound monthly, we could compound yearly, but each time I'm getting more money when I compound. We're going to take a look at compound interest in the form of a graph and in the form of numbers, because I think it makes a lot more sense when we do it that way. So again, our outside number is our principal, or our starting amount. So we're going to take $1. We're going to break it down super nice for everybody so we can understand this. 1 plus is given by the formula, because we're going to be working with percentages, and 0.5. So we're saying take 50% of what we started with and apply and give us that money. So what's 50% of $1? Well, it's 50 cents. So by the end of this transaction, we should have $1.50 based off of the numbers that we put in. How often are we compounding? We're compounding at a year. So that means when I say how often are we compounding, that is telling me when to apply this interest rate of 0.5. So at the end of the year, my dollar is going to be multiplied by 0.5. I get to keep my dollar, and I get to keep the interest that was made off of that dollar. So again, this 1 is our n. These two always have to match up. These two numbers will always be the same because we have an n up here and an n up here. And although you can't see it, this n is raised to the exponential area. And then we're going to say for time, 1 year. So at the end of the 1 year, we indeed get $1.50. Let's look at that in the form of a graph. So instead of a 1 here, instead of at the end of 1 year, I want to look at what happens if I just continue this on forever and ever. So instead of 1, we're putting x, and we're going to take a look at this graph. So we see that when we're working with compound interest, it is an exponential function. And let me bring up the calculator because I want this to make sense again. Let me minimize. There we go. Alright, so we're going to take $1. At the end of the year, we are saying multiply that dollar by our rate. Our rate is 0.5. I want 50% of the money I'm giving you today. At the end of the year, you give me that interest. Okay? 50 cents. Half of $1 is what we get, right? Because I put in $1, that is the dollar that I still own. So I'm going to add $1 to the 0.5 that I get in interest. And that's what this crazy expression is showing us over here. I just broke down the math a little bit nicer for us. Now, if you put your money in a traditional bank like Chase or KeyBank or Wells Fargo, their rate is not going to be as generous as this. They're going to give you something like 0.0001, we'll say, right? Maybe even 1 less. There we go. And you will see And you've seen, if you looked at your bank statement, they typically give you a couple cents back in interest at the span of the year, and 12 cents if you're getting, you get 12 cents at the end of the year because you're getting basically a cent a month. So when you're looking for your banks, you want to tend to go with people that are going to offer you higher interest. Okay, that's my little side rant. I'm going to click this on, and we're going to look at what's happening at x is equal to 1. Now, what does it mean by x is equal to 1? That's what's happening at the end of 1 year. And when I go over here, we again see, at the end of 1 year, I will have $1.50. So let's apply this again. At the end of the second year, what are they going to do? They're going to take our balance now is 150. We're going to multiply that by 0.5, which is our rate, and I get 75 cents. What do I do with that 75 cents? That 75 cents is my interest that I earned on the money that I had in my bank. How much money did I have in my bank? I had $150. And now I have $2.25 by doing nothing and having a good rate. Now what happens when I increase this to 2? You better believe at the end of the second year, there we go. At the end of the second year, I have $2.25. This is what that is showing me. And then what happens when I change this up to 2? Boom. Why isn't it showing $2.25? Because we are applying that old traditional bank rate. That's garbage. We don't want that rate. We want our 0.5. And there it is, our 2.25. All right, I'm going to end it there because I believe that shows you the power of compound interest and what compound interest is. It's basically a snowball effect. You put money in, it applies a multiplier to it, you keep it in, and it keeps multiplying